An embedding is a special format of data representation that can be easily utilized by machine learning models and algorithms. The embedding is an information-dense representation of a semantic meaning of a piece of text. Each embedding is a vector of floating point numbers, such that the distance between two embeddings in the vector space is correlated with semantic similarity between two inputs in the original format. For example, if two texts are similar, then their vector representations should be similar. While it may be convenient to represent tokens as simple IDs, especially creating an index for all the words in the vocabulary, they don't tell us anything about the meaning of words or the relationship between them. To create a vocabulary that encapsulates semantic relationships between the tokens, we have to define contextual vectors, known as embedding. Vectors are a multi-valued numeric representations of information. For example, 10, 3, 1 in each numeric element represent a particular attribute of the information. For language tokens, each element of a token's vector represents some semantic attributes of the token. The specific categories of the elements of the vectors in a language models are determined during training based on how commonly words are used together or in a similar context. Vectors represent lines in a multidimensional space, describing directions and distance along multiple axes. It can be useful to think of the elements in an embedding vector of a token as representing steps along a path in a multidimensional space. For example, a vector with 3 elements represent a path in a 3-dimensional space, in which the element values indicate the unit traveled forward, back, left or right, and up or down. Overall, the vector describes the direction and distance of the path from the original end. The elements of the tokens in the embedding space each represents some semantic attributes of the token, so that semantically similar tokens should result in vectors that have a similar orientation. In other words, they point in the same directions. A technique called cosine similarity is used to determine if two vectors have similar directions, regardless of the distance, and therefore represent semantically linked words. For examples, the embedding vectors of dog and puppy describe a path along almost identical directions, which also fairly similar to the directions for cat. The embedding vector for skateboard, however, describes journey in a very different direction. Some of the best practices here, we have to verify inputs don't exceed the maximum length. The maximum length of input text for our latest embedding models is 8,192 tokens. We should verify that the input don't exceed this limit before making any request. If sending an array of inputs in a single embedding request, the max array size is 2048. And finally, when sending an array of inputs in a single request, remember that the number of tokens per minute in your request must remain below the quota limit that was assigned at the model deployment. By default, the largest Generation 3 embeddings models are subject to a 350K TPM per region limit.